Hey everybody, this is Mr. Regner, and I'm looking here at page 338, which is our Chapter 7 practice test. So I'm going to run through these questions with you here on the video with the goal that you can kind of use this video how you would like. So I'm going to put my question number like this on my paper with a big circle around it so you can kind of scan through the video and find the ones that you need to look at. So without further ado, let's get started with number 1. Now we've got a parallelogram here. It tells me that the base is 130 centimeters, the height 100 centimeters. I'm just going to use my area formula. Area equals base times height. And I'm going to plug in those numbers that I know. So 130 is my base, and the height is 100 centimeters. So I can use my calculator for this to make it easier, but I also can just use my simple mental math here. If I'm multiplying anything times 100, I'm adding on 2 zeros. So that's 130 with 2 more zeros. That's 13,000 centimeters squared. That's the area of number 1. Moving on, here's number 2. You can see the shape here is a triangle. It looks like we've got a what might be a base of 22 and a height of 14, or I guess it could go either way. We're going to use our area formula for a triangle. Area equals 1/2 times base times height. Now again, depending on which angle I look at this, if I rotate my book around or whatever, the base or the height might change. It doesn't really matter as long as I make sure that I'm multiplying them both together. I'm going to call this 22 times 14. Now, for me, personally, I might do this mentally again, because look, half of 22 is 11. And then 11 times 14 might be one that I could do. Think 10 times 14 is 140, and then one more 11, that's 151. That's 151 inches squared. We always square our units when we're talking area. Let's move on. Take a look at number 3. You knew this was coming, right? We had a parallelogram, we had a triangle, now we've got that trapezoid. Remember the area formula for a trapezoid. 1/2 times the height times the sum of the bases. I like to think big B, little b. You could do B1 plus B2. Doesn't really matter. So the area equals, let's see, our height is going to be 2 centimeters. So 1/2 times 2 times the sum of my bases, which are 2 and 4/10, plus 1 and 6/10. Okay, order of operations says 2.4 plus 1.6 is first because I'm adding them in parentheses, right? So 6/10 plus 4/10, just thinking this through mentally, that's 1. 2 plus 1 is 3, plus that other 1 is 4. So my area is 1/2 times 2 times 4. 2 times 4 is 8, and half of 8 is 4. The area here equals 4 centimeters squared. So again, notice, first 3 problems, we need to know our area formulas. So make sure you've got those in mind. All right, moving on to number 4. Number 4 is a triangular prism. Now, when I think about a triangular prism for number 4, I think about making a net. We're going to take the 3D version and make it 2-dimensional to help myself out. So a net for a triangular prism, we have like our flat part, the top, this is like the bottom, that's like the other side. I didn't really draw this to scale very well, did I? And then we have our triangle bases. Okay, it kind of looks like a little bird or an airplane, right? So now we want to label all of our parts. So if I think about my triangle, I have a triangle that is, let's see, 12 as its base, and the height is 5. So the base is 12, the height is 5, right? 12 and 5. If these two edges are touching, then these are also 5s, right? And then on the other side, we have that 13 up here being labeled as that diagonal line. This diagonal line is 13, which means this is 13, right? 13 and 13. I guess we could say this is 13 also, if need be. And then we have that 7-foot part. That 7 foot would be like all of these diagonal lines going across here. I guess I'll just kind of label some of them so we get the idea. Now from here, think of this like a composite shape. You're just going to find out what is the area of the rectangles, what's the area of the triangles. We have enough information here to do that. And so I'm going to call these, I guess I should kind of call them what they are. We got the bottom, the side, the other side, the bases. I'm going to start with my bases. Remember, area equals 1/2 times base times height because they're triangles. So I'm going to plug in the information that I know. I know the base is 12 and the height is 5. 12 and 5, they're identical. So it doesn't really matter which one I look at. 12 times 5. Now, just to kind of get you in the habit of using your calculator, of course, you can always pull out that calculator. This is the TI-30X2S. It's a good one to use. If you want to use it, you can. Mentally, though, half of 12 is 6, and 6 times 5 is 30. So I know this is 30 square feet for one base, right? I know I have two bases, so keep that in mind. For this side, which I guess I'll just call it side, I have area equals base times height because it's a parallelogram, and the base and the height is 13 times 7. So 13 times 7, I'm just punching that into my calculator to make it super easy for myself. I get 91. So I'm going to put 91 in here. I guess I should have put this 30 in here. I like the idea of putting the areas inside those boxes. Maybe you like that too, maybe not. That's okay. For the bottom, again, it's a parallelogram, so base times height. I'm going to plug in the numbers that I know. It's 12 and 7. So 12 times 7. 12 times 7 is 84. And if you're thinking I did that math super quickly, I did because I did it on the calculator. And then I have my other side. I guess I'll call it side 2. Why not? And it is 5 by 7. So area equals base times height. Plug in those bases and heights. 5 times 7. 5 times 7 pardon me, is 35. And now we have 35 here. Add them all together, right? I'm going to use my calculator just to make it a lot easier. Not absolutely required, but it might help you. 91 plus 84 plus 35 plus 30 plus 30. That's going to give me a total surface area, or SA, which is 270 square feet. That's the areas of all of my faces. Notice I just found the area of one base, 30, but that actually is the same area for both of my triangular bases. That is number 4. Moving on to number 5. Number 5 is a triangular pyramid. Let's see if we get this going. There we go. Triangular pyramid. If I make a triangular pyramid, it's a pyramid that has a triangle base. So I have a triangle base and then triangles coming off of all those sides. Right? Here's my base. Here's all my lateral faces. There are 3 of them. Let me try to label some of the information based on what I see. The base of all of my sides is going to be 9.5. 9.5. The height of all of those lateral faces is 15 meters. And then the height of my base triangle is 11. That's 11. This is hard to label. 11, and of course 9.5 is the base. So I'm going to first start off by finding the area of the base. Use my formula for a triangle. Area equals 1/2 times base times height. Plug in my base, which I know is 9.5. Plug in my height, which I know is 11. I'm going to go ahead and do this on the calculator again just to make it quick and easy for myself. So I have 1/2 times 9.5 times 11, and I end up with an area that is equal to 52 and 25/100ths, or 52 and 1/4. I guess I should probably label that as meters squared. Then all of my lateral faces, all of these outside triangles are going to be the same. So they're all triangles, 1/2 base times height. I know the base is going to be 9 5/10, and I know the height is going to be 15. So again, I'm just going to plug that into my calculator. Do 1/2 times 9 5/10 times 15, and I end up with an area that is equal to 71 and 25/100ths. All right, so we're thinking, great. There's one base, there's 3 lateral faces, so I need to add them all together. Or I could take 71 and 25/100ths and multiply it times 3, since I know there's 3 of them, and then add on 52 and 25/100ths. Either way, the surface area equals 266 square meters. I had to find the area of each of my faces and add them all together. That is number 5. Let's move on. Take a look at number 6. Now, number 6 says, find the volume of the prism. Well, remember, volume equals length times width times height. We need to remember that formula, and if we remember that formula, this is a simple problem. So let's just plug in some of those numbers. The length looks like it's maybe 3/2. The width is 5/4. The height is 7/3. Right? So we're just going to multiply these numbers together. Now keep in mind they're improper fractions, but I'm not scared of that. I really hope you can see my calculator because I'm going to show you a little trick here. Right? It's this ABC button. Can you guys see that ABC button? It's not coming up too well, but it's basically just 1 over and 3 down. It says ABC. That button allows me to type in fractions into my calculator. So if you have this version of the calculator, you can do this. So I'm going to type in 3/2, or 3/2, by typing 3 ABC 2. That's 3/2. I'm going to multiply that, so times 5/4. That's 5 ABC 4. That ABC acts like a fraction bar. I'm going to multiply that times 7 ABC 3, 7/3. I'm really just multiplying all those numbers together here on my calculator. Could I do it without a calculator? Sure, I probably could, but the calculator makes it so much easier. I come up with this answer, which I hope you can see on your screen. It says 4U 3/8. That U just separates the whole number from your fractional part. So I'll say the volume equals 4 and 3/8. Now remember these are all centimeters. So I'm going to say centimeters, but I'm not talking area, so I can't say centimeters squared. Instead, I'm going to cube it. Centimeters cubed. That's how we label our volume. So the answer here is 4 and 3/8 centimeters cubed. Let me move on and take a look at number 7. There we go. Now number 7, again, looks to be a cube, right? We're trying to find the volume of that. Still a prism. So we use the same formula. Volume equals length times width times height. Now I could plug this in as 4/5 times 4/5 times 4/5. And I really would not have a problem doing that, right? But if you would prefer, we could think of this as being the same thing as 4/5 to the 3rd power. That's really what it is, right? So every cube, you can think of it that way. If I write that in here in my calculator, I think you can kind of see my screen, hopefully. I'm going to write 4 ABC 5ths. And, oops, I guess maybe just to be sure, yeah, I'll do this. I'm going to use this little caret button. You can see that little caret button sort of just to the corner of the 7. That means I'm going to have an exponent. So I have 4/5 with an exponent of 3. If I hit enter, I end up with 64 over 125. Let me write that down. 64, 125. And that would, of course, be yards cubed. Now, just in case you are curious or how this might look, what if I would have done it the other way? What if I would have done 4/5 times 4/5 times 4/5? So 4ABC5 times 4ABC5 times 4ABC5. I get an answer of 64 over 125. It's the same thing. So again, it wouldn't really matter which way you do that. I also could have done that by hand, right? 4 times 4 is 16, 5 times 5 is 25, and then 25 times 5 is 125, and 16 times 4 would be 64. So I could have done that without a calculator as well. That's number 7. Let me move on and let's take a look at number 8. Number 8 says, draw an octagonal prism. I almost said a rectangular prism. An octagonal prism. So remember when we were drawing these out, we always start with the name of the prism, the octagonal prism, starts with an octagon. So I'm going to draw out an octagon, which is an 8-sided shape. Think of a stop sign. You guys know my art skills are nothing to be to write home about here, but I have 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sides there. I'm going to draw an identical octagon, or one that's pretty close to it, up here. Okay, just kind of off to the corner. Now, if I think about this, I have vertices here. Every time my edges come together, those are my vertices. I'm drawing these out intentionally because we're connecting all those vertices when I combine them. So I'm going to start with my upper left one here, and I'm going to try to make a straight line, or as straight as I can, to connect it. I'm going to go with my upper right one and connect them. Boop, there we go. And just kind of make my way around the octagon, connecting all these dots. There we go. Now that looks kind of crazy on my page. Remember, we could also, if I had the ability to erase some of these lines, we could erase some of those invisible lines to make it a little bit easier or clearer to see. But that is an octagonal prism for number 8. Let's move on and take a look at number 9. Get my page all aligned. There we go. Number 9 says, find the number of faces, edges, and vertices of the solid. So faces, edges, and vertices, the old FAV. So if you look at that solid, we have, let's see, a 1, 2, 3, 4, 5, 6, a 6-sided shape that's been moved into a prism. It's like somebody took a hexagon and just stretched it out, right? We have a hexagon on the top and on the bottom. There are 6 sides to a hexagon, so that means I'm going to have 6 lateral faces. Those rectangles that connect my two hexagons are going to be 6 of them. And I can count them up. 1, 2, 3 on the front, 1, 2, 3 in the back that I can't see. So there's 3 lateral faces and 2 bases. What did I just say? There's 6 lateral faces and 2 bases. So 6 plus 2 is 8. That means there's 8 faces in that shape. I also need to find the edges. Now, it may help you to kind of redraw this or kind of trace over the edges. I'm going to try to explain this, and maybe I can use my mouse here to kind of help you out. So I have an edge here. 1, 2, 3, 4, 5, 6. There are 6 edges in that hexagon. On the bottom, there's 6 more. That's 12 edges so far. And then I can't forget about my lateral faces, right? Because there's edges there. So there's 1, 2, 3, 4, 5, 6. So I have 6 on the top base, 6 on the bottom base, and 6 in my lateral faces. 6 plus 6 plus 6 is 18. What did I just do here? Why do I have A? I meant that to be an E. Edges. What is going on here? You guys are probably watching this thinking I'm loony. All right, so I've got 18 edges, 8 faces so far. Now for my favorite one, the vertices. Remember, this is where the edges come together to make a point. If you draw this out, you might make those vertices really stand out with big giant dots. But think about it. In every hexagon, 1, 2, 3, 4, 5, 6, there are 6 vertices. You have a hexagon on the top, a hexagon on the bottom. There's 6 vertices on the top, 6 on the bottom. 6 plus 6 equals 12. There are 12 vertices there. I hope that makes sense. On our test, you'll want to make sure that you're able to identify faces, edges, and vertices for any given shape. Whenever they give you a 3D shape, can you find the faces, edges, and vertices? Let's move on, and let's take a look now at number 10. Number 10 says, the area of a parallelogram is 156 square meters. What is the height of the parallelogram when the base is 13 meters? Huh? Now, you might have to look at this a little bit closely. Maybe you even want to draw it out, right? There's my parallelogram, which is not drawn very well, but you get the idea. It says the area is 156 meters, square meters. Area is 156. The height is unknown, and the base is 13. So there's my base, 13. The height is unknown. I'm just going to use my area formula. Area equals base times height. I'm going to plug in what I do know. I do know that it's 156 for the area. I do know that the base is 13, and I don't know the height. Guys, this takes me back to the section on solving equations. Look, we want to get h alone. How do I get h alone? By using my inverse operations. I have 13 times h. I want to divide 13 on both sides. The 13s cancel each other out. I'm left with just h. And on this side, I have 156 divided by 13. And again, if we can use our calculators, we might as well do that to make the math work a little bit easier. 156 divided by 13, I get an answer of 12. I could have solved that on paper. It probably wouldn't have been that tough, but it's easier with the calculator. So the height is 12. And just to make sure that I'm super, super clear, I could even say 12 meters. 12 meters. That's the height of that parallelogram they were describing on number 10. As I scroll down here, there we go. Now we're looking at number 11. All right, so number 11. Whoop. Move my page up a little bit. It says a candle is shaped like a square pyramid. Find the surface area of the candle. And the candle is given to you here in this drawing. This yellow thing is the candle, right? It does look like a square pyramid. We want to find the surface area of that square pyramid, so I might think about drawing out a net. Remember, a square pyramid has a square as its base, and all of the lateral faces are triangles. So I have a square, which is 4 by 4, so all of these are 4s all the way around. And then the triangles will have a base of 4 and a height of 3.6, or 3 6/10 inches for the height. So I'm just going to use my area formulas again. So the base is a square, base times height. Substitute that in, that's 4 times 4. The area for the base is 16. And then for my lateral faces, or my triangles, the area equals 1/2 times base times height. That's 1/2 times 4 times 3 6/10. Now again, we might make this really simple. 1/2 of 4 is 2. We could do 2 times 3 6/10, or we could use our calculator. Either way, we get the same answer, so don't feel bad either way you're doing it. But we should get an answer of 7 2/10, and that would be square inches. I guess I should put that on there for the lateral faces. Remember, there's one base, there it is, and there are 4 lateral faces. If it helps you, maybe you want to write in 16 here and 7 2/10 in all of these. You can do that if you'd like to. At the end of the day, I'm adding up 7 2/10 4 times, so multiplying it times 4, and then I'm adding that with 16. When I add those all together, I end up with an answer of surface area equals 44 8/10 square inches. That would be the surface area for number 11. Let's move on. Take a look at number 12. Number 12 says, you are wrapping the boxed DVD collection as a present. What is the least amount of wrapping paper needed to wrap the box? All right, so we're talking about this box here that's shown about space. What a great gift, by the way. We want to know the least amount of wrapping paper. So in other words, if we were wrapping this up, we just want to cover the surface of that box. We don't want to have any overlap. What we're trying to find here is surface area. You guessed it. It's a rectangular prism, so we could draw out our net if we would like. This is going to be a bad drawing of a net, but you get the idea. That sideways T is our net for a rectangular prism. Now what that means is we've got 6 different faces, a top and a bottom and a front and a back, a top and a bottom, a side and a side. But remember, there's a little trick you might use. Do you remember this trick? I'm going to try to draw this out like super, super quickly. And not so well either. But you get the idea. Since we know the 3 dimensions, we have 6, 8, and 1 5/10. Remember our trick where we can just multiply by working around in a circle, and then we've found the areas of the 3 faces, multiply that by 2. So I can take 6 times 8 plus 8 times 1 5/10 plus 1 5/10 times 6. take all of that and multiply it times 2, and that's our little hack to finding the area of a rectangular prism. Again, to make life easier, you may want to use your calculator. We could punch in that entire expression into our calculator and get our answer. So I'm going to do that. We have 2 times 6 times 8 plus 8 times 1 5/10 plus 1 5/10 times 6, end parentheses. Now, as long as I've typed this in correctly, and I think I have, but if you make a mistake typing it in, you can always go back using those arrows. If I hit enter, I should get the surface area, which is 138. Surface area is equal to 138, and because we're talking about inches, we'll say square inches. So I need 138 square inches of wrapping paper to cover that DVD box set. Again, the shortcut works every time. I didn't show this part, but if we wanted to, we could label all of the spots here on our net. We could find the area of each individual rectangle and then add them together. That's just an alternate way of doing it, which I think you'll find to be more time-consuming, but still accurate. Let's move on. Take a look at number 13. And there it is, number 13. It says a cube has an edge length of 4 inches. You double the edge lengths. How many times greater is the volume of the new cube? Whoa. All right. So for this one, I recommend kind of setting this up like it's 2 separate problems. Okay, there's our first cube that has side lengths of 4 inches. That's 4, 4, and 4. For the volume here, think length times width times height, or 4 times 4 times 4, right? Or think of that as 4 to the 3rd power. Either way, if you do this on your calculator or whether you do it by hand, we come up with 64. 4 times 4 is 16, and 16 times 4 equals 64. Now it says that if we double the edge lengths, that means we're going to take 4 times 2. Now we have volume equals length times width times height. That would be 8 times 8 times 8. Well, again, we could think of that as 8 cubed if we would like to. We could think 8 times 8 times 8 as well. Either way, we end up with a volume of 512. Now that's all good and dandy, and it's important to know that information, and that helps us to find the answer to our question, because the answer is, how many times greater is the volume of the new cube? Well, this cube was 64 cubic inches. This cube is going to be 512 cubic inches. I want to figure out, what am I doing to 64? How many times do I have to multiply that to get to 512? Another way to think of it is, what's 512 divided by 64? Because that'll also get my answer. So I'm going to do that. 512 divided by 64. 512 divided by 64. You could punch that in a calculator. We could do the division. Either way, we end up with 8. That means that this new cube is 8 times bigger. And there we go. So that problem, I don't think it's going to be too difficult, but trying to understand what they're asking may be a little bit challenging. So read it carefully, take your time with it, and do the math. Let's move on. Take a look at number 14. Here we go. It's the last question on the page. It says the Pentagon in Arlington, Virginia is the headquarters of the U.S. Department of Defense. The building's center contains a pentagon-shaped courtyard with an area of about 5 acres. Find the land areas in square feet of the courtyard and the building. Whoa. All right. If you look at this in your book, or even just on your screen here, you can see all those crazy dimensions. There's a lot of dimensions happening there. All right. We want to figure out in square feet the land area of the courtyard and the building. So let's start with the entire building, right? I'm going to try to draw this out on my page just so we can kind of all see the same things. That's a horrible pentagon, but you get the idea. That's kind of what the building is shaped like, right? It looks like they've chopped this up already into half right there. They've said this is 1,490 feet, right? They said this right here is 541 feet. And look, that looks like a triangle, doesn't it? And up here, this looks suspiciously like a trapezoid. Amazing. So they have 1,490 feet here. This top one is 921 feet. Hey, that would be both of our bases. And then they tell us that the height here would be 876 feet. So guys, we really just have two shapes to worry about, a triangle and a trapezoid. This is just a composite shape, really. Right, so let's start with a triangle. Area equals 1/2 times base times height. Plug in our info. Area equals 1/2 times 1,490 times 541. Boy, these are big numbers, so I'm going to take out my calculator here and help myself make this easier. So I'm going to go 1/2. I could do 1 ABC2 times 1490 times 5, oops, see I messed up there, 541. The calculator only does what you put into it. Remember that. We end up with an area of 403045. Yikes, that's 403,045 square feet. But we're not done yet. That's just the triangle part. That's just this part. We've got to worry about that trapezoid too. Remember the area formula for a trapezoid. 1/2 times the height times the sum of the bases. Let's plug in the information we have here. We know the height is 876. We know the bases are 1490 and 921. So I'm going to plug those into my calculator again, making this work a little bit easier. So I have 1 ABC2 times 876 times, in parentheses, 1490 plus 921, end parentheses, and my area of just the trapezoid part is 1056,018. Add some parentheses, we get 1,056,018 square feet. Now you guys know where I'm going next, right? Composite shapes, add them together. I'm going to take this amount, which I already have in my calculator, and add on this amount. So I'm just going to put plus, that's going to say answer is plus 403,045. That's probably the Pentagon calling me right now on my phone to let me know. So the surface area here, I shouldn't say surface area, the area, all of that together is 1459063. So we have 1,459,063 square feet of the outside building. So the building is ginormous, right? If you didn't realize that before, now we have the exact numbers to help us out. All right, so now it says, what about the land areas of the courtyard? So let me go back to that question again. It says the building's center contains a pentagon-shaped courtyard with an area of about 5 acres. I feel like this is kind of a tricky question. I don't really like this question, and there won't be anything like this on the test. But assuming we knew how many square feet there were in an acre, we'd be able to answer this much easier. I will just tell you this right now, that 1 acre is equal to 43,560 square feet. Again, not very fair of a question for you, so I apologize. But if we know this information, now we can answer this question. It tells us the courtyard is 5 acres. So if it's a 5-acre courtyard, think we're taking 1 times 5 to get 5 acres. So we need to take 43,560 and multiply times 5 to figure out how many square feet that would be. So again, I'm just going to make life easier for me here and type this into my calculator. So I think you can see my screen. That's 43,560 times 5. We end up with 217,800. That's 217,800 square feet. I don't like that question a lot because it gives the impression that we should just know that, and that might not be something that we know. In fact, I don't think we've ever had to learn that or studied that so far. So that would be a tricky one. If there's ever a question like that, though, you would be given the information you need. Here, I think they're assuming you know more than you do for this problem. So there you go. Those are the 14 questions on the Chapter 7 practice test from page 338. Use this practice test to help you prepare for our actual test, because the questions here are similar to the types of questions you might see on the actual test. Good luck. If you have questions, always feel free to send me an email, and have a fantastic day.